Welcome to this specialized training module on information systems acquisition and development. Today, we are focusing on the backbone of successful IT initiatives, project governance and management. We will explore how organizations align IT projects with business goals, the structures used to oversee them, and the specific tools managers use to ensure delivery on time and within budget. Let's begin. To understand project governance, we must first look at the hierarchy of work. It starts at the top with portfolio management. This is where executives decide what to do based on strategic alignment and ROI. They manage investments. Below that is program management. A program is a group of related projects like a digital transformation program that includes separate projects for cloud migration, new software, and staff training. Finally, we have the project itself. A project is temporary. It creates a specific deliverable. Governance is the thread that connects these layers. It ensures that the project manager's daily work actually ladders up to the company's strategic vision. Without this alignment, you might successfully build a system that the business doesn't need or can't use. This diagram illustrates the flow of value and authority. At the very top are the strategic business goals. These drive portfolio management, where decisions are made on where to invest money. Notice how the portfolio feeds into programs, like Program A. Program A then coordinates specific projects, such as software development and infrastructure. These projects produce deliverables, which ultimately flow back up to provide value to the business goals. It's a closed loop of governance. Governance is executed by people. The most critical body is the IT steering committee. They don't manage the project, they steer it. They approve major milestones and resolve conflicts between departments. Then we have the project sponsor. This is the person with the money. They authorize funding and remove barriers. The project manager is the captain of the ship, managing the daily details of time, scope, and budget. We also must include user management to ensure the thing we build is actually useful. A key concept here is the separation of duties. The person building the system, project manager/team, cannot be the same person approving its quality or auditing its compliance. Here we see the governance reporting structure. Senior management empowers the IT steering committee. This committee provides oversight to the project sponsor. The sponsor then grants funding and authority to the project manager. The PM directs the development team and user reps. Crucially, notice the dotted line from the steering committee to quality assurance. QA should report independently to governance, not to the project manager, to ensure unbiased reporting. Before a single line of code is written, we need a business case. This document justifies the investment. It details the problem, proposed solution, and expected benefits. Closely linked is the feasibility study. Just because we should do it doesn't mean we can. We look at economic feasibility. Will we make money? We use metrics like ROI and net present value. We look at technical feasibility. Is the tech mature enough? And operational feasibility. Will our staff actually use it? These documents are the primary inputs for the steering committee's go, no-go decision. If the business case is weak, the project should be rejected immediately. This flow charts the birth of a project. We start with a business need. This triggers a feasibility study. We ask, is it viable economically, technically, and operationally? If yes, we formalize it into a business case. This case goes to the steering committee for a decision. Only if they approve does the project move to initiation. This gatekeeping ensures resources aren't wasted on doomed projects. Once a project is approved, it follows a standard lifecycle, often remembered by the acronym IPEMC. Initiating is where we get the project charter signed. Planning is the massive effort to define scope, schedule, and budget. Executing is where the actual work happens, building the software. Monitoring and controlling happens simultaneously with execution. We compare actual progress against the plan and manage changes. Finally, closing involves formal acceptance and the post-implementation review. You cannot skip phases. For instance, executing without a plan is a recipe for scope creep and failure. This diagram shows the project lifecycle. It starts with initiating, moves to planning, and then to executing. Notice the loop between executing and monitoring and controlling. This is the heart of project management. If monitoring detects a deviation, we loop back to planning to adjust. Once the work satisfies requirements, we exit the loop and move to closing. In the planning phase, we use specific tools to organize chaos. The most fundamental is the work breakdown structure, or WBS. It takes a massive project and breaks it down into small chunks called work packages that can be assigned and measured. We might also use an object breakdown structure, OBS, to map out the system components. To visualize time, we use a Gantt chart. This shows us the schedule linearly, highlighting start dates, end dates, and dependencies. If you don't know the dependencies, you can't build a realistic schedule. These tools allow the project manager to track progress accurately. This is a simple work breakdown structure. The main project, new ERP system, is at the top. We break it down into phases: requirements, development, and testing. Then, we break those phases down further into work packages like interview stakeholders or database config. This decomposition continues until tasks are small enough to estimate and assign. How do we know how long the project will take? We use the critical path method, CPM. In any network of tasks, the longest path determines the project end date. If a task on the critical path is delayed, the whole project is delayed. Tasks not on the critical path have slack or float. For estimating the volume of work, we move beyond guessing. Source lines of code, SLOC, is an older method counting code lines. A better method is function point analysis, FPA, which looks at the complexity of inputs and outputs, making it independent of the programming language. We might also use PERT, which calculates a weighted average of best case, worst case, and likely scenarios. This network diagram illustrates the critical path. We have two paths from start to end. The top path, task 1 to task 3, takes 5 plus 3 equals 8 days. The bottom path, task 2 to task 3, takes 2 plus 3 equals 5 days. The top path is the longest, therefore it is the critical path, highlighted in red. Any delay in task 1 will delay the project end. Task 2, however, has slack. Once the project is running, how do we know if we are winning or losing? We use Earned Value Analysis, EVA. It compares what we plan to spend against what we actually accomplished. If you spent 50% of the budget but only finished 20% of the work, EVA will flash a warning light. Another control technique is time box management. This is often used in agile development. We freeze the time and the budget. We say you have 2 weeks. What changes? The scope. We prioritize features and drop the less critical ones to meet the deadline. This prevents projects from dragging on forever. Finally, formal change management is vital to stop scope creep, unauthorized additions that blow the budget. The final phase is project closing. This isn't just stopping work. It requires formal acceptance signatures from the sponsor. We must archive all records for future audits. Crucially, we conduct a post-implementation review. This doesn't happen immediately. It happens after the system has stabilized. We ask, did we actually get the ROI we promised in the business case? Did we meet the requirements? We also capture lessons learned, not to assign blame, but to update our processes so we don't make the same mistakes on the next project. This feeds back into the portfolio governance. Closing the loop. The timeline for closing extends beyond the project end. First, we have deliverable acceptance, and the team is released. Then comes a period of stabilization, where production support takes over. Finally, well after the dust settles, we conduct the post-implementation review to measure ROI and verify controls. This lag ensures we are measuring the real-world impact, not just the project output.